So following on from the previous video, we got to this stage here where f prime equals this thing. So in the previous video, we've established that when n equals 1, the first term of the sequence will be 0, and then by looking at f prime, we could tell that it's going to climb at first, and then later on it's going to fall. So it's not going to be monotonic. But the point here is that we will need to establish this. This is going to be our upper bound here, and our lower bound will be when n. Our lower bound will be 0, because if you look at this thing here, this thing is always going to be positive, and this thing here is always going to be positive. So you've got a positive and a positive. It's never going to enter the negative realm. It's never going to enter the negative realm down here. So the lowest point will be the lower bound would be 0. But then we would need to look at the upper bound here. We would need to establish our upper bound here. We know that it's going to climb and then it's going to fall. So to establish this turning point, we need to find out when the derivative will be 0. We would need to find out when the derivative will be 0, because here the derivative will be 0. So set the derivative to be 0. And by the way, if you get a graph plotter and plot this, if you cheat and get a graph plotter and plot this, it will look like this. So the lowest point is, well, remember, when we're dealing with sequences, n can only be whole integers, so we don't really care about anything below here. And then this thing here, well, it's never going to be 0. It's never going to touch 0 again. And then here, we want to find out the highest. By looking at the derivative, we've established that the sequence is going to climb and then later it's going to fall, and it looks like this. Well, anyway, we will need to find out where along here the gradient will be 0. So we will want to find the upper bound here. The upper bound will be when the derivative is 0. So hang on. So set the derivative. So this was our f prime earlier. F prime equals this thing here. So set f prime to be 0. So find out when the derivative will be 0. So from here, times both sides by this, that will then give you this, and then add this to both sides, that will then give you this. Divide both sides by 9, that will then give you this, and then e equally to both sides, that will then give you this. And as it turns out, it will give you this. So going back to so 1.95. So 1.95 is when the gradient will be 0. But then we are working with sequences, so it can't really be 1.9. The nearest one, because it's always falling from here onwards. It's always going to decrease from here onwards. So the next biggest one will be when n equals 2, because we're working with integers when it comes to sequences. The point here is that the sequence, the upper bound will be when it's at 2. But let's just keep it simple. Let's just say the upper bound will be this. Let's just say the upper bound is e. Even though we should consider 2, but let's keep it simple. E to the power of 2 over 3. So what we can conclude is that our sequence here has to be equal to or lower than e to the power of, what was it, 2 over 3? Now let me check. No, 2. Yeah, 2 over 3. So the sequence itself has to be below or equal to, well, this is our upper bound. The lower bound will be 0. So this here is this is our upper bound. This is our lower bound. And by the way, it's not monotonic because it's climbing and then it decreases. So it's not monotonic, but it is bounded. Upper bound, lower bound. Okay.